Now, I'm going to discuss to you some of the exercises on your module. Okay. Now, let's have here. Let's answer this. Okay, let's have here number 1. You are asked with the GCF of 20, 24, and 40. So, you will use prime factorization here. 20, 24, 40. Okay, for 20, that is 4 times 5. Or that would be 4. That is 2 times 2 times 5. For 24, that would be 4 times 6. That would be 2 times 2. 6 is 2 times 3. Since that is not the same with 5, so do not align it with 5. So we have here 2 times 3. And then 40 is 8 times 5. So 3 2s. So 2 times 2 times 2, since that is 8. And then times 5. Okay, then get the GCF. Okay, so when you say GCF, greatest common factor, so just get the common factors. So 2, another 2. So that means to say the GCF is 4. Okay. Now let's have your number 2. In number 2, you are asked with the GCF of x squared and x to the power of 9. Class. Just what I gave you a tip. The GCF or a variable. So just pick the variable who has the least exponent. That is the GCF. So this means to say x squared. Okay. Let me explain to you. So you have your x squared. That is x times x. While x to the power of 9. That is x times 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 x. So 9x. Just get their common times another x. So very clear. X times x is x squared. So tip for variables class with exponent, just pick the variable with the least exponent. Okay. Number 3. So for number 3, you are asked here for the GCF of x, y to the power of 10, x to the power of 4, y to the power of 6, x to the power of 9, y to the power of 9, and then y to the power of 10, and y to the power of 10. Just what I told you, you just pick the variable who has the least exponent. So among the x, so x is the variable who has the least exponent. So x. And then for y, so you have your y to the power of 10 to the power of 6 to the power of 9 to the power of 10. So meaning y to the power of 6 as the least exponent. Okay. Number 4. You are asked here to factor completely 7x minus 7. So what we will do here? 7x minus 7. Okay, get the GCMF. GCMF is 7. And then you divide each term by the GCMF 7 minus 7 over 7. And this becomes 7 times 7x divided by 7, that is x, minus 7 divided by 7, that is 1. As I told you, class, you can check your answer if it is correct or not. You can multiply 7 times x, that is 7x. You get the correct first term. Then 7 times negative 1, that is negative 7. You get also the second term. Okay, next. Let's have your number 5. For number 5, you are asked to factor completely 2x to the power of 6 minus 12x to the power of 4. Okay, let's factor that. 2x to the power of 6 minus 12x to the power of 4. So for this class, you look for the GCMF. GCMF is 2x. Okay. So you get the variable was the least exponent, which is 4. So 2x to the power of 4. That is the GCMF. And then divide each term by the GCMF, which is 2x to the power of 4 minus 12x to the power of 4 divided by 2x to the power of 4. And then, so you have here 2x to the power of 4 times 2x to the power of 6 divided by 2x to the power of 4. That means to say 1x or 1 or just x. Then subtract the exponent. 6 minus 4, that is 2. Minus 12 divided by 2, that is 6. And then x to the power of 4, x to the power of 4, you need to divide it. That is equal to 1. Or just cancel it out. So meaning x squared minus 6. Okay, so this is the complete factors of 2x to the power of 6 minus 12x to the power of 4. Okay, let's have number 6. You're asked here, you give the perfect square expression. You're asked with the perfect expression. You have your choices. A, that is 3x squared. 3x squared is not a perfect square, of course, since 3 is not a perfect square. Okay? And then B, you have your B, 4x. 4 is a perfect square, but x is not a perfect square. So, this cannot be a perfect square expression. Okay. Another one, 9x cubed. 9 is a perfect square, but x cubed is not a perfect square. So, meant to say that is not a perfect square expression. Okay, letter D. Letter D, here you have your 16x to the power of 4. 16 is a perfect square. X to the power of 4 is a perfect square. How? Okay, when you're going to express that into perfect square, into the power of 2 or perfect square expression, that becomes 16 is 4, and then x, that is it. So, since it can be expressed the power of 2, that means to say that is a perfect square. So D is the answer. Okay, let's have your number 7. For number 7, you're asked for an expression which is a perfect cube. So, perfect cube expression. Okay, so letter A, you have your 8x. 8 is a perfect square, but x is not. So, this cannot be a perfect cube expression. Okay, next. You have here 27x squared. 27 is a perfect cube, but x squared is not a perfect cube. So this cannot be a perfect cube expression. Okay, letter C. You have here 64x to the power of 6. Okay, let us express this into perfect cube expression. This is 4x squared quantity cube. So very clearly, 64x to the power of 6 is a perfect cube. So C is a perfect cube expression. But how about letter D? Letter D is 125x to the power of 4. Yes, 125 is a perfect cube. That is 5 cube. But x to the power of 4 is not a perfect cube. So D cannot be a perfect cube expression. Okay. Now proceed to number 8. For number 8, you're asked to factor z squared minus 16. Okay, this is very clear. This is a perfect square. The difference of two squares. So let us express each to the power of 2. 16 is 4 squared. Okay, so this is difference of two squares. Expected that we have two binomial factors here. So factors of z squared. So z plus minus 4 squared. That is 4. Okay. Okay, so when you get the product of the binomial z plus 4 and the binomial z minus 4, you get z squared minus 16. Okay, number 9. You have here factor also y to the power of 4 minus 49. Okay, let's do that. Y to the power of 4 minus 49, of course, this is difference of two squares since the two terms are perfect square. So express each to the power of 2. So y squared quantity squared minus 49 is 7 squared. So that becomes y squared plus 7 and y squared minus 7. Okay, now proceed to number 10. For number 10, you are asked to factor 27 m cubed plus 1. Okay, for this class, this is sum of two cubes. Okay, so 27 m cubed plus 1. So since it's sum of two cubes, so express each to the power of 3. So 27, that is 3, then m cube, m quantity cube, then plus 1 cube. Then you can now get the two factors, which one is binomial and the other is trinomial. So let's get first the binomial factor. So base of first term, that is 3m quantity cube, so that means to say 3m. And the second term base is 1. Then from your binomial factor, you get your trinomial factor. Square of 3m squared. And then you minus, you multiply the 2, 3m times 1. And then you square the third, you square the the second term to get the third term square. Okay, simplify. So you have your 3m plus 1 times square of 3m, that is 9m squared. And then multiply 3m times 1, that is 3m. Then square of 1, so 1 squared. Okay, that's it. Now let's have your number 11. Number 11, you factor also x squared y squared minus 1. Okay, this is very clear. This is difference of two squares. So express each into the power of 2. So x, y, quantity squared minus 1 squared. And then you get the two factors, which are base of first term, xy quantity squared, that would be xy. Another one here, xy plus, and then you get the base of 1 squared is 1. The other, by the way, is minus 1. So they are the factors for x squared, y squared minus 1. Let's proceed to number 12. You're asked here to prove to factor m cubed minus 125. Okay, this is a very obvious. This is difference of two cubes. So express each term into the power of 2. So m cubed minus 5 cubed. Okay, get their binomial factor, which is the base m and the base 5. And then get the trinomial factor, square of m, then multiply the 2m times 5 to be plus 5m, then square of 5. Square of 5 is 25. Okay, that's it. Okay, number 13. Okay, for number 13, you have your 27b cubed plus 64k cubed. Okay, this is also the sum of two cubes. 27b cubed plus 64k cubed. Express each to the power of 3. So this would be 3b quantity cubed plus 4k quantity cubed. So meaning the binomial factor would be the base 3b plus 4k. And then square of the first term of binomial factor, which is 3b squared, minus multiply the two terms 3b times 4k, and then plus square of 4k. Okay, simplify. So you have 3b plus 4k, square of 3b, that would be 9b squared, minus 3b times 4k is 12b k, square of 4k, that would be 16k squared. Okay, they are the factors of 27b cubed plus 64k cubed. Okay, let's have here number 14. Okay, for number 14, you're asked to factor 5a to the power of 4 minus 80. Okay, in this case, class, this is not difference of two squares nor difference of two cubes. So, in that, maybe they have GCMF. Yeah, they have the GCMF. So, factor first the GCMF, which is 5. So, that becomes 5a to the power of 4 divided by 5 minus 80 divided by 5. So you have 5 Then 5a to the power of 4 divided by 5, that would be a to the power of 4 minus 80 divided by 5, that would be 16. And next, you factor a to the power of 4 minus 16. That is difference of two squares. So express each into the power of 2. A squared, quantity squared, minus 4 squared. Okay, let's factor. So that becomes 5 a squared plus 4 times a squared minus 4. But notice plus a squared minus 4 can still be factored out. That is difference of two squares. So, very obvious. That would be a plus 2, since 4 is 2 squared, times the quantity of a minus 2. Okay, they are the factors of 5a to the power of 4 minus 80. Okay, let's have another. Number 15. That is 54 x cubed minus 16 y cubed. Yes, as you observe, that is not difference of two squares or difference of two cubes, but because they have GCMF. Okay, their GCMF is 2. Okay, factor 2. So 54x cubed divided by 2 minus 16 y cubed divided by 2. So this would be 2 times 54 divided by 2, that's 27 x cubed minus 16y cubed divided by 2 is 8y cubed. So very obvious that 27x cubed minus 8y squared as y cubed is difference of two squared. Difference of two cubes rather. So, we'll continue here. 27 x cubed minus 8y cubed. So, first express each term the power of 3. So, 3x cubed minus 2y quantity cubed. And then get their binomial factor, which would be 3x base for first term minus 2y base for second term, and then get their trinomial factor, which is the square of 3x plus, multiply the two terms of the binomial factor, 3x times 2y plus square of 2y. So you have here 2 times the quantity of 3x minus 2y times square of 3x is 9x squared plus 3x times 2y, 6xy, and then plus square of 2y, 4y squared. Okay, they are the factors of 54x cubed minus 16y cubed. Okay, for more videos to come, please subscribe our YouTube channel. Thank you. God bless.